Okay, folks, what do you want to look at? If you have questions about the upcoming homework assignment, or maybe the last homework assignment.
Look, that's homework assignment. The last homework assignment, please.
Yeah.
Like dimensionally correct.
Oh yeah. All right. Let's see. Most of you had trouble with the third one, I think, which was it was like, what was it? mv over t. Is that equal to force or something like that? Right? The trick on this is, one, you have to know what F is. I told y'all that in class in an email, I think. But F is actually equal to the mass times acceleration. So that's kilogram meters per second squared. And then the other thing that people often mess up on is that they take this m right here and they say, oh, they just carry it down as m. But m is really not meters, right? It's kilograms. And so that's just a matter of confusion, that you just sort of get messed up in your variables and your units. But you have to be careful of that m is not in meters, that m is a measure of mass. So be careful when you're going from variables to units. So that's kilograms, and then v is meters per second. And then t, another thing is that sometimes people would put the s up here, but as you know, that's not correct. That the t actually goes down here. So I'm left on the left-hand side with kilogram meters per second squared, and then on the right hand also with kilogram meters per second squared. All right? So that was sort of, if you missed that one, it's probably because you missed that one dimensional analysis. So this is actually how Newton first represented Newton's second law, not as mass times acceleration. Oh, we haven't done the second law, sorry, but we will. F equals ma, right? I've heard of that before. He represented in terms of momentum, which we'll see that in chapter 5. Okay? With those, we can do some dimensional analysis if you like. You want to do some dimensional analysis, or we can move on and look at kinematics.
Analysis.
All right, let's do one-dimensional analysis, and then we'll move on to some kinematics problems. So, like, for example, I'm just going to do this one right here. Did we do this one last week? No? Y'all are sure? Yep, this fall 17. Oh, okay. All right, well, let's look at this one then. Which of these equations is dimensionally correct? Let's look at this one right here because it looks really complicated, right? But remember, on these, when you come up to them, you want to first cancel out everything that you can. So like I can get rid of the m's, which are a measure of mass, just dividing through. And then I say, well, what is v squared? V is meters per second, and then that's squared. That's that one. And then what is x? Well, x is meters. A is meters per second squared. So far, we're okay, that those have the same units. And then recognize that I don't include the half. It doesn't have any units at all. It's just a constant with no units. That should be equal. That should be positive there. And x is in meters. T is in seconds. So meters squared per second squared. So that one is correct, too. So that one is okay. And in fact, we can look at some of these others, and you might be able to even say, well, I know that v times t is the same as x, so far we're okay there. I can cancel out my x's here and here, and then it's just a matter of, is v squared over a, is that meters? Can you think about that in your head? Is v squared over a have units of meters? Let's take a look. So v squared is meters per second squared, and then over a, that would be second squared over meters. It helps to write it out, so make sure that you write these things out. Don't just try to think of it in your head. In fact, we did a paper a couple of years ago where we looked at people's tests in this class and looked at how much they wrote on their test and correlated it with their grade. And we found that people who wrote more, this shouldn't surprise you, people that wrote more on their test, that they just made higher grades. A lot higher grades, actually. So it really does help. I've seen students turn in exams, and they have nothing written on the exams. It really does help to write a lot on the exam. even if you have no idea where to start, just start writing down stuff that you know about the problem, and then often you'll sort of, it'll get the juices going, and you'll figure out, okay, well, this is what I need to do next. You can think through your pencil really nicely. So I recommend that you do that. But listen, let's look at some, if we have time at the end, we can come back and look at dimensional analysis, but let's look at some of this more recent material like kinematics. Oh, goodness, let's see. And then if y'all want, we can look at some vector problems. It's not really any new material, it's just trig, but we're going to see it soon in chapter 3. Okay, let's look at this. This is a graphical analysis problem. You're going to have to do this on the test. I have 4 graphs, and I want to know which of these graphs represent the motion of a car with negative acceleration and positive velocity. So let's think about this. Positive velocity, that means that this position versus time graph will have to have what will have to be true about it? It has a positive velocity. That's right. The slope needs to be positive. And then if it has negative acceleration, what does that mean it's doing?
The slope's going to have to curve down.
You're right, but let's not get ahead of me. You're right there, Ross. That's awesome. So, it has to have a positive slope, and if it has negative acceleration, is it speeding up or slowing down in this case? It's slowing down. They're opposite, right, but it doesn't have to be slowing down. It's only because I have positive velocity that they're opposite that it's slowing down. So I'm looking for something with a positive slope that is slowing down. Which one do you think, Bree? D is right. So notice here my slope is positive and it's decreasing. I have a positive slope here and it's decreasing. That means I have positive V, and because it's slowing down, the acceleration is opposite that. You will have cases like that where I give you some physical scenario and ask you to show me the graph that describes that scenario. Courtney?
Is the acceleration at any point positive?
Not on this graph. No, the acceleration is never positive on this graph. Which of these have a positive acceleration? A. Any others? B as well. Because B, notice, it has a negative velocity, but it's slowing down, so it has a positive acceleration. You didn't think that, right? It's because it's opposite, that I can have a positive acceleration and still be slowing down. Let's look at another one. Oh, look, y'all had this one on the OpenStax thing, or something very similar. I think it was the same one, actually. It is the same one. There you go. The answer is 96. They had this last year as well. So you will see some problems that are verbatim from OpenStax.
How do you get that?
Okay, so if I want to find the distance traveled on a V versus T graph, the distance is given by the area under the graph. And so here you need to find the area under this graph. Now this isn't a simple one-piece graph. I have to break it into 2 pieces. I find the area of that graph, or that part, and the area of that part. This is just a triangle right here. So I do 1/2 base times height. That's the area of a triangle, right? Half of a square. That's half of 4 times 12, which is going to be 24. And then the area of this thing, 4 to 10 at 6 on this side, 12 on this side. 6 times 12 is 72, plus 24 is 96. You'll certainly see questions like this. If I wanted to find the instantaneous, number 21, the instantaneous acceleration at V, boom, tell me what's the answer. What is it, Courtney? It's 0, right? Because to find the acceleration on a V versus T graph, I need to know the slope of that function at that point. And it's a nice flat function at that point. So you don't really need to go any farther, no calculation or anything. You say, oh, that's a 0 slope. Now, if you're looking for the acceleration, say at point A, then I would need to find the slope. And that's going to be 4 over 2 I didn't count the squares. I looked at the axes. Here to here is 4. Here to here is 2. All right? All right, let's look at some sort of more standard kinematics. Are there any on here? There should be. Okay, let's look at number 14. I think this was actually from OpenStax too. So with these kinematics problems, you want to start, you just sort of look at it, it's a big jumble of words and numbers and letters, okay? But you just start and you go through and you begin writing down the things that you know. So, a swan on a lake. It's a swan. Wait, that doesn't really matter, okay? So don't worry about what it is. It gets airborne by running on top of the water. It must reach a velocity of 4 meters per second. To take off, it accelerates from rest. So that tells me that V naught is equal to 0 meters per second at an average rate of 0.2 meters per second squared. So A is equal to 0.20 meters per second squared. Okay, and is it positive or negative? Well, in this case, my velocity, I'm going from 0 to positive 4, and I'm speeding up, so that means my acceleration is also positive. These things might not be explained to you explicitly in the problem, but when you think about the scenario, then you can begin to see it. All right, so the acceleration is that, and that's all I got. I'm asking how far does it travel? If it helps, you can draw a picture. Like I have this swan. It has to go from V equals 0. Here's my swan. It has to go from V equals 0. It runs along, and it wants to get up to V equal to 4 meters per second. And I need to know how long, or what is the distance required for it to skim along the top of the water until it takes off. Okay, next, I would write down my equations. I have V equals V naught plus AT, and X is equal to V naught T plus 1/2 AT squared. Listen, you do not have an equation sheet, but these are really the only equations that you'll have for this test, these two. So write them on a card, carry them around within your pocket, just internalize them. Make sure you know them backwards and forwards, okay? Well, I know if I'm going to find X, that I have to use this. That's really the only way I can find X. But notice that I don't know T. Like I don't know X, and I also don't know T. And so I can't solve that equation for X, right? Because I don't know T. I have two unknowns. But I do know, I know V, I know V naught, and I know A. And so now I develop this plan of attack. How to solve this? I first solve this for T, and then I solve this for X. Okay? You will have some problems that are 2 steps like that. Now let me just warn you, in some of your homework problems, we have systems of equations. And we'll work those periodically through the semester because it's useful for you to be able to solve a system of equations. That's when you have 2 equations with 2 unknowns in each equation. And you can solve a system of equations. You have to have as many equations as you have unknown variables. So if you have 3 unknown variables, you need 3 independent equations. If you have 4, you need 4. If you have 100,000 unknown variables, then you need 100,000 equations. And people do that. They solve these big systems of equations. Usually in like particle dynamics. That's where you have a bunch of particles moving around. And you can just write a computer code and solve those equations. But here we just have 2. And so it's not that hard. So first I solve, so anyway, on those homeworks where you have those systems of equations, please know that you're not going to have to solve a 2x2 system of equations, 2 equations, 2 unknowns in each on the exam, just because it's cumbersome. It takes a long time to solve those. And then you make one little mistake and it messes up your answer. But you will have to do questions like this. So first I solve for t. I'll go ahead and put in my values. 4 is equal to 0 plus 0.2 times t. And so 4 divided by 0.2 is equal to t. That's equal to, what, 20 seconds? So it takes 20 seconds for him to take off. And then I solve now for x. X is equal to v naught, which is 0 times 20, plus 1/2 of a, which is 0.2, times t squared, which is 20 seconds squared, and that's equal to 40 meters. Is that right? 0.1 times, yeah, 40 meters. So the answer is D. I was a little sloppy with my sig figs, but my lowest number of sig figs here is 4. And if you're careful, you'll get out that you need to keep 2 sig figs there. Okay, that's a good example of a kinematics problem. It won't be that problem, of course, but it'll be something similar where, and you'll follow the same procedure. You'll go through and you'll write down the things that you know, write down the things that you need to know. You might even want to draw a picture to help you think about what's going on in that problem. Courtney. Yeah, that's your initial velocity, v naught.
Is that always 0? Or
No, it's not always 0. In fact, you had, what was it? I think it was the car problem where it was backing out. V naught wasn't 0 in that case, right? Whether it was backing out of the driveway or something and want to know how long it would take to stop. And so in that case, v naught was not 0, but v final was 0. That's just the v was 0.
So the not stands for initial.
That's right. Not actually stands for t equals 0. So t at 0, the position at t equals 0 seconds.
Okay.
Okay? Y'all good on that, you think?
Okay. At least I know what it is. Now I know. Because I know what V naught is.
Yes, that's important. All right. Listen, I'm taking Hebrew this semester. I'm not sure if I told y'all this, but Hebrew is it looks like an alien language. You sit down and you look at the letters, and they're just like.
That's why I think that's why I always say about like Middle Eastern writing and just any form of like Asian.
Yeah.
Asian.
It's just so different. The alphabet is so different.
Sloppy for that for us.
You're right. And I know that physics, for some of you anyway, I think we're probably looking at some of the best students here, but I think that for some of you that physics is probably that way too. It just looks sort of like you haven't really thought about things in that way. And that's okay. And you know what, the class is going to get harder, but that's okay. We're just sort of assimilating some of the vocabulary and the techniques that we use right now. Same with me learning Hebrew. Like, it's really hard right now because I have no idea what the alphabet, the letters, the sounds they make, how you write the letters. Y'all feel that way?
Like, so basically, it's like trying to learn a new language. You just need to learn the vocabulary, you know.
Mm-hmm. So what I've decided to do is to trust my instructor that I will be able to learn it. Because right now it doesn't feel like I'll be able to learn it. But I trust him that if I just do these assignments as we move along, that eventually I'll learn it. Can y'all do the same thing?
Yeah.
Okay.
What's the worst that can happen?
All right. Well, I mean, I can imagine what's the worst that can happen. But we won't talk about that here. So you drop an object. Which of these best represents the position versus time graph? I like this problem. You drop an object because it's just saying some thing that occurs. I drop this thing. How would I describe the position versus time graph? Well, first of all, how would I describe the velocity? Is the velocity initially big or small?
Big and small.
Wasn't that look that I gave you? The squinty eye? Yeah, it's initially 0, right? I drop it, and then it gets bigger. Is the velocity negative or positive, or does it change?
What's going down is negative.
You're right. It's always negative. So it starts out small and negative, and then it ends big and negative. So which of these is that? Starting out small and negative, the velocity, and ending big and negative. C is right. Look at this. So the velocity starts out right here, really small and negative, and then it speeds up, but in the negative direction. Is speeding up in the negative direction. The acceleration then is what? Positive, negative, 0? Yeah, it's negative. All right, so I have negative acceleration because speeding up, negative velocity, so the velocity and the acceleration have to be in the same direction. Okay? Man, like these problems. Ooh, 19. Describe the motion for the object for these 3 time periods. Like, I like the calculation problems, but I really enjoy these problems even more because it just sort of picks at your mind about, do you really understand how things move and how we represent them? Let's look at this. So the object has positive acceleration for A. Is that true? Does it have positive acceleration?
No,
Why not?
because it's curving down. Or because it's turning straight.
It's a little more complicated than that. It is slowing down, and it has positive velocity. So both of those have to be true. Because just because it's slowing down doesn't mean that it's negative acceleration. But in this case, the velocity is positive, and it's slowing down. So I know that it has negative acceleration. I'm just going to write that. So that's not the answer. B could be the answer. Let's see. Is the object slowing down? Yes. Is the object at part B, is it speeding up?
No. No, it's constant.
You're right. It has a constant speed. Because look, it's a straight line. So that's not right. I can get rid of that one. Does the object have negative acceleration? Yes. Does it have 0 acceleration in part B?
Yes. At a constant.
Yes. Awesome. Does it have a constant negative velocity in C?
Yes.
Yes, because the slope here is negative. So C is the answer. Isn't that a great question?
Why is the acceleration 0? Can you explain that?
Oh, because in part B, the velocity is constant. Right, the slope of that thing doesn't change right there. And so if the velocity is not changing, that means the acceleration is 0. You follow? Yeah. That's a good question. We should have a similar question on the test in a couple weeks. But not the same, but similar. Right? I agree. Okay, let's see what else we got here. Y'all want to look at the F-15? I know y'all have that in front of you. I know that. But that's not F-15, is it? All right, let's do number 13. You're almost certainly gonna have a type of problem like this when we do free fall, because it's important for chapter 3. We're sort of just getting a little bit into kinematics, but then in chapter 3 we're gonna dig a little deeper because we'll see kinematics in 2 dimensions. We'll do it a little bit more complicated. All right, you throw a ball up with an initial speed of 30 meters per second. I like to draw a picture. I throw a ball up. The initial velocity is positive 30 meters per second. All right, when I put the little dot at the end, remember that makes the 0 significant. So it has 2 sig figs. And I want to know what is this distance. I'm going to call it y because it's vertical. I also know that the acceleration is negative 10 meters per second squared. I might have mentioned this. I'm not sure if I did. But I will on Monday when we have class. That the acceleration is always... We don't have class on Monday.
Yeah, we don't.
No class on Monday.
So
Wednesday. I'll see you. The acceleration in the y direction is always minus 10 when you have something in free fall. Or something that's moving with respect to the Earth. And I want to know what y is. Well, I'm sort of missing some information. I'm going to write my equations over here. V is equal to V naught plus AT. Y is equal to V naught times T plus 1/2 AT squared. We used to write that with an X, but now I'm going to start writing it when it's vertical with a Y. You'll see, it'll be more important in chapter 3 because we'll have to write all those, like 2 sets of equations with Y and X. And then I go through and I ask myself, what do I know and what do I not know? Well, I know A. I don't know T. I know V naught. I know V naught and A, but I don't know T. Do I know what V is? V is the velocity at the top. Do I know what that value is? It's 0. All right, we did that today. All right, it stops up at the top. All right, so the velocity at the top is 0. Now, I know this, and I know this, but I don't know Y and I don't know T. So this is a similar problem like the swan, where it's 2 steps. Yeah, I solve for T, and then solve for Y. So, solve for T over here. I say V is equal to V naught plus AT. That's 0 equals 30 minus 10 times T. And so T is equal to 3.0 seconds. It takes 3 seconds to travel upwards, given it 30 meters per second. That sort of makes sense, right? Because my acceleration is minus 10 meters per second squared. That means for every second, the velocity changes by 10 meters per second. So if I start at 30, after a second, I'm at 20, then I'm at 10, then I'm at 0. So it takes 3 seconds. Then I say, well, what is Y at that point? That's going to be 30 meters per second times 3 seconds minus 5. That's half of 10. Notice I gave a negative sign for my acceleration, times 3 squared. Let me write this out, actually. What I did is I said 1/2 plus 1/2 of negative 10 meters per second squared, 3 seconds squared. But I just shortened that, did minus 5. And so that's 90 minus 45. So the answer is C. All right? This was 2 sig figs right here. That's 30. Good example of a kinematics problem. You're going to have one. It probably won't be exactly like this, but I might ask you, we'll do some more like this, but you'll have one similar to this. Because it's important for you to get free fall right now before we go into chapter 3. I can do that? It's only hard when you don't know how to do it. When you know how to do it, it's not that hard, right? That's the hard part, is getting to know how to do it.
Can you have a pen?
Sure. Okay, so first, I gave a little hint here just so you didn't gloss over it. 100 kilometers per hour. We have to convert that to meters per second. So 1 hour is 3,600 seconds, 60 minutes in an hour, 60 seconds in a minute. And then 1 kilometer is 1,000 meters. And so that's equal to 100,000 divided by 3,600. 28 meters per second. Is that right? No, 27.8 meters per second. That's going to be my final speed. So that's equal to V. You might have caught on to this. I'm not sure if I said this explicitly. But when I give the initial speed, I call it V naught. But the final speed is V. V is the speed at time t. So that's usually my final scenario. All right, so V is equal to 27.8. It accelerates at a constant rate. That's my speed. The time that it takes is 8.00 seconds. Oh, it's at rest, so that tells me what my V naught is. It's 0 meters per second. And then I want to know what is the speed after the first 5 seconds. So 2 steps here. First of all, I need to find the acceleration. Hold on, let me not get ahead of myself. Let's write our equations over here. V is equal to... What's that?
Yeah, it's just supposed to be 0.
Is what 0?
V naught 0.
Yeah, V naught is 0 because it's at rest. V is equal to V naught plus AT. X is equal to V naught T plus 1/2 AT squared. You with me? I'm looking for this, but I want to know that at 5 seconds. I have it at 8 seconds, but I want to know what is the speed at 5 seconds. But in order to get that, I have to know V naught. That's okay, I got that. And I need to know A. So I need to find the acceleration. That's not given. But look, I have this information, so I can find the acceleration given that information. So I say V is equal to V naught plus AT, and I solve that for A. That's 27.8 equals 0 plus A times 8. Solving that for A. We get 3.48 meters per second squared. And then I do the exact same thing again. I plug in 5 seconds instead of 8. That's exactly right. So V naught plus AT. V naught is 0 plus A, which was given, or no, I found this, 3.48 times T, which is 8.00.
It's 5.
Look at me, I just missed the problem. All right. 5.00, so that's about 16 or so. 17 must be the answer. Yeah, Justin?
You didn't really have to do all the math, because if you look at the question, it's asking for what is it at 5 seconds, and once you
You're
have
right.
the velocity, everything else is over that. So
Awesome.
it has to be
I
something
could have
to-
stopped right here. As soon as I got that, you're right. I didn't have to do all that business. Look at me. I just wasted like 4 minutes, 2 or 3 minutes.
Why didn't you have to move?
Because at 5 seconds, he has to be going some speed slower than 27.8. Look, all these are bigger than 27.8. Clever. All right? But that's how you do it. It won't always work out that nicely, but that's how you do this. All right? What else do I want to look at here? Look, here's a problem. Remember, we worked one earlier, and we found the time for a ball to go up to some height. I think the initial speed, yeah, we found the time. It started at 30 meters per second. How long did it take to get up to the top? 3, right, 30 meters per second. Every second, it decreases by 10, so it goes 30 to 20 to 10 to 0. So what's going to be the total time for this object to go up and then come back down again? 6 seconds. We'll talk about that on Wednesday when we come back, how the time to go up is the same as the time to go down. But look, now you already know it. Seems like you're ahead. You don't have to come on Wednesday. No, you should probably come. We'll talk about other things too.
Sounds probably best.
Probably best, yes. All right, so the answer here is going to be 6 seconds.
So,
11, you want to do number 11? All right, so just going to sort of start writing down the things that I know here. V naught is equal to 4. Rolls down a hill with constant acceleration of 1.6. You got to be sort of careful here. Like I have a ball that's rolling down the hill. The initial velocity is in this direction, and my acceleration is also going to be in this direction. And so I'm going to take both of them to be positive. You could take them both to be negative. In fact, if you drew your hill the opposite way, like if you drew your hill this way, with acceleration and velocity in these directions, those would really be negative velocities. It's really how you draw your coordinate system. But in this case, just that you're consistent is fine. So I'm going to give them both positive values. The ball reaches the bottom of the hill in 8 seconds. And I want to know what is the velocity at the bottom of the hill. Oh, look, I don't even need to write out all the equations because looking at those, I'm so familiar with them because I've been looking at them for like a week on a little note card. I just, they just pop in my head. V is equal to V naught plus AT. If I want to know the final velocity, it's going to be 4 meters per second plus 1.6 meters per second squared times 8 seconds. That's 4 plus 12-ish, 16. Oh, it might be 17. It was probably 17. Yeah. Okay. Look at some Courtney.
I got it in a completely different way. I didn't use that equation.
That's wrong. No, tell me. No, what'd you do? You might be right.
I mean, that works. But I
It might not always
used,
work.
the average velocity and put in, let's look into that. 17, put that 17 by 1, 18.6.
Yeah, it only works. Choose the average velocity. A is equal to delta V over delta T, which is really the same, right? Let's write that. A is equal to delta V over delta T. That only works because the average acceleration and the instantaneous acceleration are the same, but that's always the case for this course, right? That our average and our instantaneous are always the same. That's just saying that if I look at my V versus T, it's always going to be a straight line. But that is true for this course. But if I write this, it's the same equation. A is equal to V minus V naught over T. Don't you see? That's the same equation. So yeah, that's perfectly fine if you want to do it that way. When you get your test in a week and a half or so, is it 2 weeks? What day is it on? What day of the week is that?
It's a Wednesday.
Wednesday.
It should be a week and a half, I guess.
Yeah, it's a week and a half. Yeah, we'll get to chapter 3. We'll get vectors on there. It's going to be okay. We have 2 days next week, and then we have the Monday for some review stuff. What was I going to say? Oh, so when you get your test, you'll have a form on the front. That's where you're going to bubble your answers. And there'll be a little block there where you can write stuff in it if you want to use scratch paper. I mean, you can write on the exam, too. But I recommend that you just write out all the equations that we've had. Like if you're not real quick with your trig functions, you might want to write those out. You write down these kinematics equations that we'll see, and really that's all that we got. If you want to write down your conversion factors for the metric system, then do that. That way you have that right in front of you for the entire exam. Yes?
When we do dimensional analysis, like 15 problems, they're trying to see if they equal out.
Mhm.
Give us like what each so they can equal out.
No, you need to know those units. If it's something that we haven't seen before, like we haven't really seen forces yet, I'll give you that. But as far as X, V, and A, I'll expect you to know the units for those. Anything else I'll give you. And I might just make up something, right? Just, yeah. If it's something that we haven't covered, which is really X, V, and A, I'll give it to you.
Do people have a hard time finishing your tests?
Yeah, it's a little tough. Because you got an hour, I'll give you an extra 5 minutes, yes. So you get an hour to do 28 questions. But you know what you can do? Is you can print out a test, set a timer, don't use any notes, and just work through it like your life or your grade depended upon it. It's not your life. It's not your life. Not even really, sort of, kind of. It's important for you to work hard, but it's not your life. Right? Right? Yeah. It's important for you to do your best, which is an A. Okay? All right. You want to do a quick vector problem while we're here? You're going to see graphs like this. We've done them in class. I think y'all are okay with those? Oh, these are all exam 1, so let's look at our exam 2. Y'all fall 15, is that right?
the fall 15 exam 2 is going to be on our exam 1?
Hold on, let me look.
They have some vector stuff on the versatile.
Yeah, but we sort of skimped on it just a little bit because we are moving, but we're not going to skimp. We're going to do it normal. Well, I didn't give them a true vector problem. Oh no, here we go. Number 25. Yeah, so this is this is what I was looking for. This is your fall 15. What is the magnitude of the sum of these two vectors? So when I have two vectors A and B, listen, you might not get all this and that's okay. We haven't covered it in class, but I'm just doing it sort of as a preview for what we're going to do on Wednesday or maybe Friday. I have two vectors. I'm going to draw them. Vector A is 11 units along the x-axis, and then vector B is 24 units at 60 degrees above the positive x-axis. So this is 60 degrees. When I do these, I want to find the x and the y components. Now all that means is I want to find the legs of this triangle, and that makes up the x and y components. Now notice the vector A, which is in red, it only has an x component. It's all in the x direction. So A is equal to AX. And then over here, this is BX, and this is BY. These are the x and y components of those vectors. So AX has a magnitude that's equal to 11. BX has a magnitude that's equal to 24 times the cosine of 60. Remember, cosine of our angle, which in this case is 60 degrees, is equal to SOHCAHTOA adjacent, that's BX, over B. B is this. I know this is fast, and I know it's all new. It's sort of new. We've done the trig, like we've done all the mechanics of this, but the way we're presenting it is a little bit different. So anyway, BX is 24 cosine 60. That's equal to 12. And then BY, in a similar way, is 24 sine of 60. Let's see, what is that? 21. That's equal to 21. And so what I have now, redraw this. I have AX, I have BX, and I have BY. AX is 11, BX is 12, and BY is 21. Now, I can add these two because they're both in the x direction. And what I get is a vector that is 23 units long and another vector that's 21 units long. All I did there, we'll talk about this next week, is I shifted this vector over. I can do that with vectors. As long as I don't change their magnitude or direction, I can do that. And I want to know what is the sum of these two vectors. That means I want to know what is the length of that hypotenuse. And so that's equal to the square root of 21 squared plus 23 squared.
So did you have to move?
It helps me to think about it. It's equal to 31. It just helps me to see that this vector, if I move it over here, that this is just a right triangle. And so to find the length of this vector, I use the Pythagorean theorem.
Well, what I'm saying is like going from the top of the 21 vector all the way down. So like where you have 11 and 12, you can just do it like the other way.
No, don't do it that way. We'll talk, it's called the tip to tail method of adding vectors. And whenever you're adding vectors, you begin at the tail of the first vector, and then you end at the tip of the second vector. Or I guess it's tail to tip. I always get it mixed up. Anyway, you begin at the beginning of the first vector, and you end at the end of the second vector. I understand what you're saying. Numerically, you come out with the same answer, but we're going to do some other stuff where we're going to kind of mess you up a little bit. That's exciting, right? Like there's some stuff that you've seen with the trig, but it's just presented in a little bit different way. But a very important for chapter 4. because we're going to get into force vectors, and we'll be doing 2D force vectors, and you need to master this as well as possible right now. It'll help you a lot in Chapter 4. Okay? Any other questions, concerns, comments? All right, let me just make sure that I got everybody's name before y'all leave.